Hi, welcome to Unit 7, Day 4, Properties of Rectangles. If you remember, we looked at the last proving parallelograms, and we did see, when we looked at example 5 on the second video, that because my opposite angles in a rectangle are equal to each other, that rectangles are indeed parallelograms. Okay, so because a rectangle is part of the parallelogram family, it has the same properties as every single parallelogram you'll ever meet. In a rectangle, my opposite sides are parallel and congruent. And again, if you don't know what these symbols mean, make sure you're also writing down the words, right? So if you are filling in your own notes, make sure you're writing down. If you don't know that symbol means parallel, make sure you write it next to the symbol. Put both of them so that you can start learning that symbol. And then congruent. Okay, so when I have a rectangle, my opposite sides equal each other and they are parallel to each other. My opposite angles are congruent. My consecutive angles are supplementary. They add up to 90. And again, if you're not remembering that, if you don't look at that word supplementary and immediately go, oh, that means they add up to 180, make sure you write that for yourself. Make yourself little extra notes. Add to 180. Okay? And then the diagonals bisect each other. Okay? And remember, if again, you need to make yourself a little note, divide in half. When we say bisect, we divide in equal halves. Okay? So make sure you're adding yourself little notes if you don't remember those symbols and those vocabulary words at this point. Okay? Now remember, in a regular parallelogram, my diagonals bisect each other, but they don't have to be equal to each other, right? So you might get two different sets of parallel or congruent segments. Okay? My consecutive angles have to add up to 180, opposite angles are congruent, and my opposite sides are both parallel and congruent. Now, what makes a rectangle, specifically a rectangle, and not just a parallelogram? Okay, so along with those properties that every parallelogram has, the extra properties that your rectangle have is that your consecutive sides are... Now, if you look at that symbol and you go, I have no idea what that symbol means, you're going to need to make yourself a little note, right? Consecutive sides are perpendicular. And if you look at that and you go, I don't know what perpendicular means, you might want to put yourself a little 90 there because they intersect at 90 degrees. Okay? So consecutive sides mean sides that are next to each other, that touch each other. So for example, this left side here is consecutive to both the top and the bottom. But I'm just going to highlight one set of consecutive sides so you can see what I mean. So they come together at a corner. That's what we mean by consecutive sides. So my corners come together perpendicularly. So that means they're perpendicular. All my angles are right. Or we could say all the angles measure 90 degrees. Okay? And then the second property that every rectangle has is that my diagonals are congruent. Okay, and again, if you're still struggling with your symbols, write down what that means. Okay, congruent. So that means this time when I draw my diagonals in, if I draw in this diagonal, and I draw in this diagonal, when I measure them, they're going to be exactly the same length. So let's say this is rectangle A, B, C, D. And again, notice I went A, B, and I didn't cross along here to put my C. I went around the figure. You can't go diagonally when you name, okay? So A, B, C, D, okay? My diagonals are congruent, so that means AC, all the way from A, all the way across to the corner C, is going to be equal to BD. Okay? Now, kind of another neat little side fact, because of the fact that my diagonals are equal, being a rectangle, and then because it's a parallelogram and my diagonals bisect each other, it really means that this is going to be cut into 2 equal pieces, and this is going to be cut into 2 equal pieces, which, remember, in a parallelogram I marked differently like that. But since these two are the same, let's say this is 20 and this is 20, when you divide them in half, each of them, they all divide into the same lengths. So on your rectangle, not every parallelogram, right? But on your rectangle, your diagonals, when they intersect each other, will actually make 4 equal segments. Okay? And kind of neat, it also makes 4 isosceles triangles, where those diagonals are the legs of those isosceles triangles. Okay, so we're not quite away from triangles yet. All right, let's look at this first example that we have here. Quadrilateral RSTU is a rectangle with diagonals intersecting at V. If RT equals 2x plus 13 and US equals 4x minus 1, find US. So the first thing I should do is sketch that picture. Be careful when you name your figures. I know I've got a rectangle, so I'm going to draw a rectangle. Okay, quadrilateral RSTU. So I can pick where I want to put R. I can put R in any of the 4 corners. I generally just go up or left. Then I need to go clockwise or counterclockwise when I put in the STU. So I can either go STU or I can go down first and go STU. What I can't do is zigzag. I can't go RS and then fall inside into the lava, right? I think about it like being lava and you have to play the lava game. You can't fall in. I can't come over here to put my T, so I can't go RS and then cross diagonally to put my T. You have to go around the figure either clockwise or counterclockwise. I generally tend to start in the upper left and go clockwise. R, S, T, U, and it tells me my diagonals intersect at V. So when I draw on my diagonals, they intersect at V. Since I have a U and a V, I'm going to try to be real careful to make sure that my U's look like U's and my V's look like V's. Okay? Now let's see what information they gave me in this picture. It says RT equals 2x plus 13. So I'm just going to mark that in pink in my picture, RT. So that is this whole diagonal here. So it's a whole diagonal. Okay, and then US is 4x minus 1. U to S, that's my whole other diagonal. So that is also, that I marked in purple, a diagonal. Okay, and what do we know about the diagonals in a rectangle? They are congruent, meaning they have equal measures. So I know that RT and US are going to be equal to each other. Okay, so RT is 2x plus 13 and US is 4x minus 1, and I know that these are going to be equal to each other. Okay, so well, let's solve this for x, right? I like to keep my x's positive, so I'm going to subtract 2x on both sides. That's going to give me 13 equals 4x minus 2x is 2x minus 1. I'm going to add 1 to both sides. And 14 equals 2x. Divide both sides by 2. And 7 equals x. Now, before we put a box around that, let's make sure we've answered our question. It says to find US. So I found x, I didn't find US. So I need to find US. US is my purple diagonal, which is 4x minus 1. So US equals 4x minus 1. Notice I left a space for x because now I know that x is 7. So US equals 4 times 7 minus 1. US equals 27. There's my answer. If I want to check my work, I know my two diagonals should be equal, so I could also check that RT also equals 27 if I plug in the 7. So let's just check that and check our work. RT equals 14 plus 13, so RT equals 14 plus 13 is also 27. So I can feel confident that US really does equal 27. All right, in the next video, we'll practice another one. This one, notice, is going to be working with my angles. So come on back for the next video to see how we work with angles in our rectangle. All right, thanks so much for watching. See you in the next video.